Alright, let's review for the test. So, we're going to have one roller coaster problem. I will give you that formula sheet, but it will only contain the formulas. What does kinetic energy depend on? What does kinetic energy depend on? What is kinetic energy? Depends on velocity and mass. What is kinetic energy? The energy of what? It's the energy of motion. What is temperature? Mm-mm. Not quite. No. So what is temperature? Do y'all not want to have a test review and just have the test now? Mm-hmm. Well, what's temperature? No, what exactly is it? It's not how cold or hot something is. It's not thermal. So thermal energy and temperature are totally different. So put your mask on. Temperature is the average kinetic energy of particles. So temperature is the average kinetic energy of particles. How fast the atoms or molecules are moving, how fast they're vibrating back and forth, that's a measure of temperature. So temperature is the average kinetic energy of every molecule of a substance. So if you add up the total kinetic energy of all the particles, so what's the difference between temperature and what's thermal energy? What is thermal energy? So thermal energy is the total energy due to all the internal motion. So thermal is due to the random internal motion of the particles and their configuration. So thermal refers to the total energy. Temperature is the average energy. Again, we already covered this. So nuclear is the binding energy inside the nucleus. Chemical is the chemical bonds between the atoms. Electrical is the motion of electric charges. What is light? What type of energy is light? Put your mask on properly. Guys, cool it. We're trying to review for the test tomorrow. So heat energy is due to the eternal motion of atoms. It's the same thing as thermal. Let's see. Well, again, we've already covered these PowerPoints. This is a review. So light is a form of an electromagnetic energy. Electromagnetic energy also includes electrical. Yes, these PowerPoints are both on there. So we went over two types of potential energies. What were they? And put your mask on properly, Thomas. No, we talked over two types of potential energies. What two potential energies? Gravitational. What's gravitational potential energy? Yeah, so it's due to position above Earth's surface. How high something is, you can increase gravitational. What's the other one? Elastic energy. And what's some examples of elastic energy, potential energy? Rubber band, spring, slinky, a bowstring. When do you know when you would have the greatest potential and kinetic energy on a roller coaster? So when would you have the greatest potential energy? At the highest point. When do you have the highest kinetic energy? At the very bottom. So when you jump up and down, when do you have the highest speed? Right before you hit the ground when you're coming down. When do you have zero speed? Yes. So most people don't realize this, but when you throw a basketball straight up in the air, it does briefly at the very highest point have no speed at all. It has positive speed going up, negative speed when it's going down, and thus it has to be right in the middle is a zero. So at one point it's completely stopped. It's only for the tiniest and briefest points, but it is completely stopped. What is mechanical energy? More specifically, it's the energy due to motion and position. So it'd be your total kinetic energy plus your potential energy due to configuration or position. So it's a combination of both. When is it constant? It's constant when there is no friction. Is energy constant? When is energy constant? Energy is always constant. Energy can be transferred between different types. So you can convert mechanical energy to thermal energy when you have friction, but energy by itself is always constant. Mechanical energy is always constant whenever there is no friction. So kinetic energy is the energy of motion. Potential energy is stored energy. Energy that is stored. It can be chemical energy where it's stored in the bonds between atoms. It could be gravitational where it's stored due to your position. Elastic, it can be stored in the rubber band or a spring. While kinetic energy has to do with motion. So, which has more potential energy? The books on the upper shelf, books in the middle shelf, or the books on the bottom shelf? Upper shelf. It also depends on mass. But they're about the same mass if you look at the green books versus the white books. The white books are definitely heavier, but the added height makes up for it. So describe in terms of potential energy and kinetic energy what would happen if you drop something. So it starts, yeah. So at the beginning it's not moving, and the moment you release it, the potential energy is being converted into kinetic energy until it hits the ground and stops. Why why does a basketball not continually bounce and move forward? What's happening to the kinetic energy? Air friction, somewhat. Mostly, it's actually hitting the ground that does the most. So whenever you bounce something over and over again, it heats up the ground, but you also hear sound. There is sound energy. So if you're hearing the basketball bounce, some of the energy is converted into sound. So according to the law of conservation of energy, energy can't be what? Created or destroyed. Mm-mm. So friction usually presents itself as heat. It's law of conservation says that energy can't be created or destroyed, but it can be converted into different forms. So when you have friction, you can have mechanical energy being converted into thermal energy. You can have some like when a basketball is bouncing, the energy isn't lost; it's just converted into a different form. So some of the energy can be converted into thermal energy. And so a basketball bouncing is due to sound and heat energy being produced. Energy isn't lost. There will be several. Oh, do y'all have homeworks and who didn't get homework yesterday or Friday? So who needs a new homework? Come collect it. Did you get one, Amanda? You had the weekend too. You don't know how to do math without a calculator? So when you burn gasoline, what energies are being transformed? So what is energy originally stored as? Chemical, which is a potential. So it's the chemical bonds, and then that's being converted into heat or thermal. And I'll put y'all's mask on.
I'm not finished.
So what about an electric heater? What is it? What is it converting energy from what to what? What energy? What's the initial energy? Electrical. An electric heater converts electricity or electrical energy into thermal energy or heat energy. So most of the test doesn't deal with math other than the first problem. Most of it talks about just energy. What kinetic energy, potential energy is. Asking questions. When would something have the greatest potential energy? When would it have the least? Know the conversions, like an electric heater. There are a few math problems, and the main math problem on the test is the roller coaster. The roller coaster is going to be worth 20 points. There will not be negative height on it. No, most definitely not. If you don't get the number accurate within 4 places, I'm counting it wrong. This is real life. I don't know if you know this. We're not in the Matrix. So, are there any questions about the test?
I got one question.
What's that? Here's the code word. So 20 multiple choice, and then there is a 20 table thing. So 1 point for every thing in the table. So a rubber band has the constant 100 Newton meters. It is stretched by half a meter. How much potential energy is stored in the rubber band? So, elastic potential energy is equal to 1/2 times the constant times x squared. X is how much is stretched by, so half a meter for x. Our constant is measured in Newton meters, so that's our constant. So K is equal to 100 Newton meters, x is equal to 0.5 meters. So that'd be 1/2 times 100 times 0.5 squared. And so we get 12.5 joules. Yes, that's it. Put your mask on. Michael, put your mask on. So are there any more questions about the test? Michael. Alright, that's it.